Hello class and welcome to lesson 6.3 exponential distribution. So let's just remember that exponential distribution is also continuous data, and the formula for exponential distribution is on your formula sheet, and I'm just highlighting it there in the box. The difference between this and others is, remember, exponential distribution, usually if we're taking a look at a decay, it goes like that, or a growth, it goes like that. So this is a decay, and a growth is kind of like this. And remember, there's asymptotic behavior, so this is an asymptote. Okay, so I forgot to write down growth. All right, so what we need to remember about this formula is K is 1 over mu, and mu is the average wait time between events, and the symbol is pronounced mu. It rhymes with few. All right, let's take a look at an example and how we do this. The important thing to remember is that if K is a fraction, we've got to be careful when we've got a fraction out front and a fraction that's negative up in the exponent. So just got to make sure we've got proper brackets in our calculator when we're plugging this in. All right, so let's take a look at this example, folks. Every 15 minutes in Canada, a person dies from lung disease. Model this situation with an equation and generate a graph. So that's A part. And then B part says to estimate the probability that someone in Canada dies from lung disease in the next 10 minutes. All right, so the first thing we have to figure out is the wait time. So if we're taking a look, mu equals 15. Okay, so then if we want to find K, K equals 1 over 15. Everybody okay with that? Awesome. And then we plug it into the formula. So y equals K, which is 1 over 15. And then E, you know that's a special button on your calculator already. To the negative 115 to the x. Okay. Awesome. Now, what do we want to do here, folks, is we want to identify what the random variable, okay? And x is the number of minutes between s. All right, so now we're going to fill out, model the situation in equation, and generate a graph. So to generate the graph, we're just going to take a look at some situations. So we're going to go every 5 minutes, okay? So what we're going to do is we're going to use this equation, and we're going to sub in, for example, x. So when we sub that in, we go y equals 115 e to the negative 15 to the 0. Anything raised to exponent 0 in the exponent is going to be 0, so it's just going to make e to the 0 is 1, right? So this is going to equal 1 over 15. Sorry, not negative 1 over 15, just equals 1 over 15, which equals 0.067. Okay, now we're going to sub it in with 5, so it's going to be 1/15. And we're going to go e to the negative 5 over 15. You can simplify that fraction if you'd like to negative 1 over 3. Plug it in your calculator and you're going to get 0.048. Okay. Then you sub in the next one. So it's going to be negative 10 over 15 as the exponent. And hopefully your calculators are working. You may need to put an extra set of brackets in on your fraction. We'll have to see how it works for you. If you're having trouble, please see me in class about these calculations. All right, we've got a couple more to go here. So when we sub in 15, it's going to be negative 15 over 15, which is negative 1 as your exponent. Plugging that in. Two left here, guys. Okay, so we've got e to the hat. I'm having trouble writing it down, so just go to the hat. Negative 20 over 15 is 0.018. Last one. All right. So now, ladies and gentlemen, we've got our relative frequency at each interval that we chose, and we are going to plug it on a graph. Okay. All right. So taking a look, ladies and gentlemen, at our intervals, okay, we could take a look at 0 to 5, and then we could take a look at 5 to 10, etc. However, we're just going to draw these and then figure out where our bars are going to be to help us with number 2. So let's identify what we've got. So 0 is 0.67. Okay. 5, we're at, so for 5, we are at 0.48, so very close to 0.5. Okay. For 10, we're at 0.34. 15, we're at 0.025. 20, 0.018. And 25, 0.013. So draw a nice smooth exponential curve. And we assume the trend goes, so we put an arrow on it. Okay. Now, folks, if I have, for example, 5, okay, that would be my midpoint. And so what parameters would I have to have 10 as my other midpoint? Well, what you want to think about, if we're trying to do some boxes here to help us calculate the area, well, if we take a look at 5 being the midpoint, that really means that 2.5 is our lower boundary and 7.5 is our upper boundary. Okay, same with 10. So 10 would be the midpoint between 7.5 and 12.5. Okay, and likewise, 0 would have to be the midpoint between 2.5 and negative 2.5 if we drew it like that. Okay, but it's off the graph, so we're not going to worry too much about that. All right, so we now have our distribution, and we've drawn a graph for lung disease. Got a title there. Okay, now we're going to answer question B, which for those who forgot, it's the probability that someone in Canada dies from lung disease in the next 10 minutes. Okay, so proper communication is probability where x is less than or equal to 10 minutes. Okay, equals, again, it's the area shaded. And that's what we're learning this unit. Okay, so we need to find out less than 10 minutes. So if we're going to take a look at 10 minutes, we've got this and anything to the left of that. So how many boxes do we have? Well, we really have one box here because that's at a different category. We have a second box here. And we have a half of a third box here. Okay, so why don't we say area 1, area 2, and area 3. Now you might be going, hey, Miss R, there's some points, for example, if I color in blue here, this actually doesn't meet into the graph. Well, usually that equals the extra outside the graph that doesn't matter, that's inside the graph. So they kind of, this is just an approximation, so the areas are generally pretty good. Okay? All right. So just remember, it's area 1 plus area 2 plus area 3. Awesome. Okay, so area 1, folks, it only has a distance of 2.5 across and 0.067. Okay, area 2 has a distance of 5 across, so it's going to be 5 times 0.048. And then area 3, again, only has 2.5. And times that by 0.034. All right, plug that in your calculators, folks. And hopefully you're getting these answers, 0.1675 plus 0.235 plus 0.085, and that equals 0.49. So, therefore, there is a 49% chance that someone dies in the next 10 minutes. Unfortunately, that's not a good news, but hopefully people are not smoking. Sorry, typo. All right. Let's take a look now. An easier way to deal with exponential distribution is to use the graphing calculator. Yeah, because the cool thing about the graphing calculator, and we'll be using it on our unit test this unit, is that we can graph it and then we can calculate the shade underneath of it. So again, I want you to write these steps down. You might want to use a separate sheet of paper or just print this off and leave it blank so that you know what buttons to press. The key is to remember when using a graphing calculator, you have to watch your brackets. You have to have lots of brackets in here in order for this to work. Okay, but being able to plug it in is pretty cool. Okay, and when we do, when you put the equation in, you've got to watch your brackets. Okay, you adjust the window in your graph. But then we use, in the calc menu, second trace and 7, and this is what's called the derivative. And if you've taken calculus, you will have a better understanding of that than if you haven't taken calculus. All right, so what we're going to do now is we're going to repeat the example from the previous page. The hard part, again, is putting in the equation. So I've got it here, ladies and gentlemen. This is what you type into Y1. Again, if you can't get a calculator at home on your computer, please come in the class and borrow one and make sure you can type this in. Okay, so under Y1, you type that in. Okay, to set your window, here, we'll do some windows up here. So you should have x min equals 0, x max equals 25, because that's the upper limit of that, and we'll go x scale equals 1. Then we go to the y side, so y min equals 0, y max equals 0.08, and y scale has to be a little smaller because of your increments. That may be something you have to play with just to get that figured out. Okay, so hopefully you've got the graph up, and then don't forget to shade it. You're going to go second trace, which gets your calculate menu up, and then you're going to press 7. Okay, and then it'll ask for some lower limits, so your lower limit is 0, and your upper limit equals 10. Why do we choose 10? Because this is the area under the graph we want shaded. Okay, so that's what the question asked, remember? Okay. All right, so after you put the lower limit and the upper limit in, it'll say something like this. F at x dx equals 0.48658. Okay. Okay. Hopefully, you have a graph. Looks like this. You see a shaded part in here, and hopefully it says that down below. Okay. So what does that tell you? It tells you 48.7%, or you could say 49 here. Pretty accurate. If you have a second, folks, try to find the probability that someone could pass away between 5 to 20 minutes, and see if you can get that shaded in. Okay, so what we want to do is have your lower limit as 5, your upper limit as 20, and it should look like this where the shade is somewhere in the middle. Try it, and hopefully you get around a 45% chance. Okay, All right. So again, if you can't get these calculators to work in at home, please come see me in class and borrow one. Get familiar with it again and make sure you're using it as much as possible. Homework here, folks, is page 421, numbers 9, and 468, number 2. Have a great day, folks, and see me if you need help.